Definite integrals can be thought of as a way to calculate the area between a given curve and the x-axis over a certain range. Let's consider the line y equals 3 minus x. It looks like this. The y-intercept is 3, and when y is equal to 0, x is equal to 3. Now we're going to evaluate 3 definite integrals, all of which involve integrating this line. Firstly, the integral from 0 to 3 of 3 minus x dx, which is 3x minus x squared over 2, evaluated between 0 and 3, which is 3 times 3 minus 3 squared over 2, subtract 0 minus 0, which is 9 minus 9 over 2, which is 9 over 2. So that's the final answer. But what does this number actually represent? What we've computed there is the area between this line and the x-axis, from x equals 0 to 3. That is, it's this triangle here. This is generally true. If we integrate a function between two limits, a and b, then the number we obtain is the area enclosed by the graph of the function, the x-axis, and the vertical lines x equals a and x equals b. Now, let's go back to our example. Remember, the area of the triangle is half the base times the height. So in this case, the area of our triangle, let's call it A, is 1/2 times 3, which is 9 over 2, which agrees with our integral as we would expect. For our second example, we have the integral between 3 and 5 of 3 minus x dx. This is equal to 3x minus x squared over 2, evaluated between 3 and 5. Which is 3 times 5 minus 5 squared over 2, subtract 3 times 3 minus 3 squared over 2, which is 15 minus 25 over 2, subtract 9 minus 9 over 2, which is 5 over 2, subtract 9 over 2, which is minus 4 over 2, which finally is minus 2. If we return to our diagram, then the area we've computed is the following. Let's call it area B. And area B is equal to 1/2 times 2, which is 2. However, our integral is equal to minus 2. That's because area B lies below the x-axis. When we're computing definite integrals, areas above the axis will be positive, but areas below the axis will be negative. Let's try one final example. The integral from 0 to 5 of 3 minus x dx. Here, part of the area is above the axis and part is below, so let's see what happens. The integral is 3x minus x squared over 2, evaluated between 0 and 5, which is, according to our previous calculations, 15 minus 25 over 2 minus 0, which is 5 over 2. This area is positive, but what does it represent graphically? Well, it represents the sum of area A and area B. But remember, since area B sits below the x-axis, it will be negative. So this integral is actually area A minus area B. That is equal to 9 over 2 minus 4 over 2, which is indeed 5 over 2. So, when integrating across a region, which will have areas above and below the x-axis, if we regard those above as positive quantities and those below as negative quantities, and then add all those areas together, the answer should be the same as our definite integral.